Hey everyone, welcome to my YouTube channel. This is my second video in a series I'm doing in which I'll be solving LeetCode problems in C#. In this challenge, AddTwoNumbers, we'll be using linked lists. And before I dive into any sort of solution for this, I like to take some time to really talk about what a linked list is and to kind of compare and contrast it to an array so that you can have more of a deeper understanding about what we're doing and why we're doing it when it comes to this solution. So I already have some definitions pulled up from geeks4geeks.org, and I like comparing linked lists to arrays because I'm very familiar with arrays, and to really understand something I don't understand, I like to compare it to something that I do understand, if that makes any sense. So looking at their definition of an array, they write arrays store elements in contiguous memory locations, resulting in easily calculable addresses for the elements stored, and this allows faster access to an element at a specific index. Whoa, what does that mean, right? The keyword here is the word contiguous, right? Looking at this picture here, you can kind of get an idea what contiguous means, right? Contiguous means neighboring or side by side or adjacent or touching, right? These elements in an array are stored in a neighboring or bordering or touching memory locations, right? And they're obviously indexed, so that when it comes to trying to find a specific element in an array, you already know the very beginning of an array is at index 0, and the very end of an array is usually at the array's length -1, right? But on the contrary, it's a little bit different for linked lists. Looking at their definition for a linked list, they write linked lists are less rigid in their storage structure, and elements are usually not stored in contiguous locations. Hence, they need to be stored with additional tags given a reference to the next element. So you can see here how they're not stored side by side. They're not stored in neighboring memory locations, right? And the only thing that connects them are these references, right? So looking at these clusters called nodes, right? These nodes contain two parts. You have some data, right? Some values, and you have some references, some pointers, right? And the very first node in a linked list is referred to as the head. And the last one is, you'll see it sometimes written as a tail, right? And you're at the last node in a linked list because the pointer points to a null value, right? When it comes to linked lists, you don't know if you're at the head or the body because, the head or any sort of node within the middle of this linked list, because if it points to another node, right, all you have are these references. The only thing you know for certain is if you're at the very last node because it points to null, right? So with this information being said and presented, I feel like we'll have a better understanding when it comes to understanding this challenge. So let's go read the description about what this AddTwoNumbers challenge is all about. So they write, you are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading 0 except the number 0 itself, right? So let's look at this picture. We have two linked lists, right? L1 and L2. Each node has a single value, right? And you can see where they're pointing to each one. They all have a reference except the last one, right? Two linked lists, each node contains a single value. Our challenge is to iterate through each of these linked lists to extract each value from each node, add them together, and then return a new linked list with that value, that sum, right, broken apart into individual single digits for each node in that returned linked list. So, in order to get started, there's one more important piece of information when it comes to linked lists that I want to talk about, and it'll really help when starting with any sort of interview question or any sort of challenge involving linked list, and that's something called a Sentinel Node. All right, and here's this Wikipedia article about a Sentinel Node. And it writes, in computer programming, a Sentinel Node is a specifically designated node used with linked lists and trees as a traversal path terminator. This type of node does not hold or reference any data managed by the data structure. So what is the point of this? What is the use for this? I also refer to this as a dummy node. And I have a little drawing here. Oh, there's a little drawing here about what a dummy node does, right? And like I mentioned before, when you talk about linked lists, right, unlike an array where it's indexed, you could always tell that array starts at index 0. You can't do that with a linked list, right? So a dummy node is used, we can use a dummy node in this instance as a sort of reference or a pointer to the head of our linked list, right? So that no matter where we are in this linked list, we always know that dummy will point to the head, right? And this is important because using this will always give us a consistent starting point, right, for our linked list. And when it comes time to return our linked list, we won't return the dummy. We'll exclude the dummy from this linked list that we want to return. But it's used, right, to keep track of where we are in our linked list. So in order to do that in C#, and again, our return type for this AddTwoNumbers method is a list node, and we're working with these input parameters of both type list nodes. So we're going to initialize a variable type list node called, I'm going to call it Sentinel. And again, with C#, we're going to have to instantiate a new list node using the new keyword. And we're going to store its value as that of 0, because again, this is just a dummy node, right? Its sole purpose is to serve as a sort of marker or placeholder for that of the head of this linked list, right? Hopefully that's pretty straightforward. So the next point that we need to think about is what can we use, right, that's very similar, that we can manually create to these indices, right, that we can use to my apologies, kind of point to certain elements within this linked list, right? And like I kind of said it, point to, we're gonna make some pointers, right? And I'm just gonna again type list node p equals L1 and list node q equals L2, and I'm gonna write one for our current position equal to that of Sentinel. And why do we want to create pointers, right? Why not use these input parameters directly? And the biggest issue that we'll have if we don't use pointers is that we won't be able to track where we are when iterating through this linked list, right? And I have another, kind of saw a glimpse of it earlier, this somewhat of a diagram here, that why it's important for us to use these pointers, because again, we can't use a for loop with the linked list, right? We have to figure out some sort of manual way to keep track of where we are in this linked list, right? And by using these pointers, it helps us maintain these references to these linked lists about where we started, right? It helps us navigate these linked lists without losing the information about where they started, right? It also helps us not only move from node to node, but allows us to iterate through these lists while keeping track of the current position that we are at, right? And you can see here, both these pointers for lists 1 and 2 are pointing at node 1. And, node 1, they go down to these integers, value 1, value 2, that we use in this equation to come up with the sum, right? And we'll go over that in a few moments. But again, we use these pointers to, again, iterate manually through each one of these nodes until we reach null, right? So that's why we want to use these nodes. My apologies, use these pointers. The second big thing that you might have seen within the equation was a carry or a carryover, right? And we need to make a carryover because in this problem, right, each node contains a single digit, right? No, not one node contains a double digit number or a multiple digit number. It's always a single digit number. So what if whenever we want to make a sum, whenever we get the sum, what if the sum is a double digit number, right? How are we going to break down this sum, right? What if we get a value of 12, right? And we need to break it down, right? We're going to use a carry, right? Just like if it was 11 plus 9, right? Look at the ones position. 1 plus 9 is 10. Write the 0 down, carry the 1, right? That's essentially what we're going to be doing if it's a double-digit number that is made after after extracting both values and adding it with the carry, right? So I'm going to initialize a variable called carry of type int equals 0. Cool. So we have all of our global variables initialized. So now we need to think about how to manually iterate over both linked lists, right? Again, we can't use a for loop. We have to use some other sort of conditional where as long as something is something, then we can do something, right? And the way I like to think about things is like when it comes to trying to navigate what to do, right? You gotta look about what you have, right? And with linked lists, the only thing you have, right? The only thing you know is whether or not the reference is pointing to another node or pointing to null, right? So if you know a node is pointing to null, that is done. But if it's not pointing to null, then it's pointing to another node, right? And if it's pointing to another node, then we want to extract that value from that node, right? And if it's null, then we need to kick out of this iteration, out of this loop, right? And return our new linked list, right? So how do we do that? And we'll do that by using a while loop. And again, we're going to be using our pointers here while p is not equal to null, right? Because again, if it's null, then it's done or doesn't exist, right? We can have, you know, a linked list with just null, right? It doesn't exist. So while p is not null and q is not null, right? Hence this logical or operator. P is not null or q is not null, right? We're going to do some stuff, right? We're going to, this is finally able to iterate through each one of these nodes within these input parametered linked lists, right? Right. So like I mentioned before, right, we're going to want to use our pointers as the sort of middleman to extract these values from these nodes and put them into our these new variables here called value 1 and value 2. And I'm just going to create them now. So I'm going to initialize a variable called value 1, type int, and I'm going to set it to equal to p val, or the value of that node, right? I'm going to do the same thing for value 2, right? And before we go any further, I'm going to add a comment here. I'm going to say extracted values from nodes into value 1 and value 2. And we're missing something very important here is the fact that what if these values are null, right? What if the values of these nodes are null, right? And we can't have that because, right, say if value 1 is 2, but value 1, let's say value 1 is 6, but value 2 is null. You can't do 6 plus null, right? You get an error. So I'm going to use a ternary statement saying that if p is not null, right? P is not null, then value 1's value is going to be that of p.val. Else, if it is null, we're going to set it to the value of 0, right? we're going to do the exact same thing for Q, right? If Q is not null, and again with ternary statements, you have this conditional, and then you have if this is true, then this, else that, right? It's like this if-else statement essentially in one line. If Q is not null, then Q.val is the value of value 2, else we're going to set it equal to 0. And now, you know, if the value of that node is null, then we'll swap it out for this integer of 0 so we don't get any sort of error when it comes to adding them together, and which we'll do right now. So I'm going to say add extracted values and carry together. And that's going to be, I'm going to initialize a variable called sum, type int equal to our carry plus value 1, like you saw in this picture, value plus value 2 within this diagram I've made here, right? So great. Now we have our sum, right? But the issue with that is that, again, if this sum is a double-digit number, right? If this sum is a double-digit number, we need to figure out a way how to break down that number from the 10 spot and the 1 spot, right? And we can do that by, I'm going to say, isolate 10 spot position, 10's position, sounds better. If we do that by, again, accessing our global variable carry and setting it equal to our sum divided by 10. And why would we do this, right? Right? This essentially represents the 10th digit of the sum, right? It allows us to, you know, if it's a double-digit number, to break it down into 2 pieces and to store that 10th position into this variable that we can then instantiate into a node if need be, if it's greater than 0, right? If it's not greater than 0, then we'll just overlook it and return our linked list, our new linked list. But if it's a double-digit number, we need to figure out, how to capture that into a variable. Right, so for instance, like if sum is 12, right? And 12 divided by 10 is 1.2, right? So we're going to get that 1 and we're going to store it in this carry variable. But the part that we're missing is how are we going to store this 1's position, right? How are we going to get this 1's position into a new node? And I'm going to write right here. I'm going to say capture and store 1's position in new node, right? How are we going to do that? And to do that, we're going to use our global variable, our pointer for current .next, meaning that the next node that we create right here, new list node, right? Essentially saying this current.next. So the next node that we're creating here, its value is going to be that of the 1's position of the sum, if the sum is a double-digit number, right? Because if the sum is not a double-digit number, right? For instance, if carry is 0, value 1 is 1, and value 2 is 1. The total is now 2, right? This is going to stay at 0, but this is going to, what we're about to write here is going to make sure that the 1's position is stored in this new node. So we're going to do sum modulo 10. And what a modulo operator does is it essentially is the remainder after division. Like I talked about earlier, if 12 divided by 10 is 1.2, 12 modulo 10 is going to be just the number 2, right? It's getting that remainder from that division. So with that being said, we've captured both the 10s and 1s position, and now all we have to do is, again, we need to iterate. We need to iterate one to the right, right? We need to, like any for loop, we need to manually iterate, right? Instead of using the or a decrement, but in this case we're iterating, we're incrementing actually. So increment our current position, right? And how are we gonna do that? We're gonna set our global variable current to a new value of current.next, right? But that's not all. We need to increment these pointers as well, right? So increment list pointers. We're going to use that by using some if statements. If p is not null, again, then we're going to say p, right, our pointer, is now equal to p.next. Same thing for our q value, our q pointer. If q is not null, q is equal to q.next. Right? And you might think that's everything, right? But we're forgetting that carryover, right? We're forgetting that we need to take into account that if this carry is, greater than 0, that we need to store this in a node, right? And append it to our new list, our new linked list, right? So I'm gonna write if carry is greater than 0, create new link, I'm gonna say create new node with its value to that of the carry, or to the value of that of carry, right? Misspelled carry there. So just like the comment even specifies, if carry is greater than 0, then we're going to do our current.next, because again, we always want to think a step ahead, right? We don't want to we don't want to modify where we're currently at, right, within the sequence. So we always want to think, ahead with linked lists. So our next current.next new list node is that of carry, right? We're creating a new list node, putting the value of whatever the value of carry is, right? If it's greater than 0, right? Else it's just going to ignore this, right? It's not going to store a random, list node of 0, right? So the last part to complete our solution is to not forget about how, going back, how we wanted to ignore this dummy node, ignore this Sentinel node, right? Because we don't want to include this random node of, with the value 0 in our linked list, because, if there's only 3 nodes, right, it'll be weird to have this 4th number. It'll knock it off by, a lot. So in order to essentially skip dummy node, we're going to return, well, actually I'm going to say return new node, return new linked list without the dummy node. Right, return new linked list without the dummy node. All we're going to do is return Sentinel dot next, right? Because again, Sentinel is acting as a somewhat of a pseudo header, a pseudo head, right? It's acting as this pseudo head that whenever we return this new linked list, we're simply saying start from the next one, right? Which is going to be whatever we calculated here. So let's run it. and it has accepted all 3 cases. So if you enjoyed this video, don't forget to like. If you had any trouble, any more confusion, anything I can elaborate more on, don't be afraid to comment down below. I'll definitely take the time to help out with whatever needed. And I hope you enjoyed it, and on to the next one.